So we want to visualize the data here and look at some descriptive statistics. To do that, I am going to first create a pandas data frame from the data. And so I'll say something here, like we could do this analysis in NumPy. So we could do our full analysis using NumPy and NumPy arrays, which are what the data currently is. So you'll see here that we have array here. And this means that this is a NumPy array, which is really great for doing computation on. That's what NumPy is especially good at, is very quick, very efficient computation over arrays like this, matrices. And you'll notice that that's different from right here. We just have a normal Python list, which is not as good for general numeric computation. So we could do our full analysis using NumPy and NumPy arrays, but we'll create a pandas data frame. We'll create a pandas data frame because it does make some things simpler, and also just to get some practice using pandas. All right. Not that you should use the real live pandas in real life for anything. You can let them be. We're going to use the Python package pandas. Bad joke. Bad joke. All right. So what do we do here? Well, we imported pandas already. So if we do pd.dataframe, this is the constructor for creating a new data frame in pandas. And if we use the question mark and then do shift enter like before to look at the documentation, we can see, okay, what does pandas want? Well, it wants some kind of data, wants you to pass in an index, or you could not, wants you to pass in columns, maybe data types. So this is a very powerful constructor here. You can pass in a lot of different types of data, and pandas can work with it. So in this case, our data is our data bunch, and then the data key within that bunch. And our column names here, so our columns are going to be our feature names. So let's just run this really quick. And we see that this gives us a really nicely printed pandas data frame with, now we have column labels, just like you would see in Excel or something like that. So let's go ahead and assign this to df for data frame here. And in addition to that, I'm actually going to go ahead and add our target here as well. And this is going to be data target. Now let's just look, we use the .head method here to just look at the first 5 rows. So sepal length, sepal width, petal length, petal width, and then we put our target in here as well, just for now, just so that we can look at kind of some of the correlations between these different features and our target a little bit more easily. And maybe while we're at it, actually, why don't we go ahead? Well, no, we'll do that later. That's fine. So one of the first things we can do here is let's look at some distributions of our features and our target. So actually, before that, let's look at some basic descriptive statistics. And in pandas, this is very easy. You just do df.describe here, call that method on your data frame, and you'll see that it returns what we saw in the dataset description as well, which is some basic descriptive statistics. So things like the mean, we see the minimum and the maximum here, which is actually very helpful, the median. So looking at this, so let's look at our sepal length. So we see that we have a minimum of 4.3, a maximum of 7.9, and a bunch of values here in the middle. And so this is very different from if we look at our sepal width. We see we have a minimum of 2 and a maximum of 4, so, 4.4. So those barely overlap in their range. And then if we look here at petal length, well, this has a huge range. This goes from a minimum of 1 to a maximum of 6.9. So that actually covers almost all of the ranges of the sepal length and the sepal width. And then our petal length, you'll see here is petal width, much smaller, going from 0.1 to 2.5. And then our target, well, we already know kind of what that is, right? It's 50 zeros, 50 ones, and 52s. Those are our different outcomes that we can have here. So we know what those look like. So next, let's look at the distributions, kind of the visual distributions, and we'll do this using a histogram here. So in pandas, very easy way to do a histogram is you just look at the column that you want to plot here, and then you call the .hist function. And so you notice this is a pandas series with a data type of float. It gives you the name of the pandas series here, and a pandas series is basically just a single column within a pandas data frame. So we call .hist, and there we go. Here's a histogram showing the distribution of this variable. So let's, let's actually say, column equals this, and then let's plot that column, and then I'm going to use this plt.soup title column here, and this will put a title on the plot there. And to keep this output from showing up, I'll just call plt.show kind of after here. That just keeps that last output here from showing up. So this is our sepal length centimeters distribution. So let's go ahead and copy this down now. And let's do this for sepal width as well. And then we can do petal length. And here you see kind of a very different shape. We've got this bump over here on the right, but then we also have, quite a few values down here as well, outside of that main distribution. So that's really interesting. And then petal width. And you'll notice here a very kind of similar distribution, other than maybe this gap here in this bar. If we wanted to, we could increase the granularity here. Let's say bins equals, what do we have now, like 10 bins? Maybe we'll go to 15 different bins. But since we don't have a lot of data here, that might not actually be the best choice. So we could leave it as 10 for now. But so we get a basic sense of the distribution of each one of our features. Although right now, that is maybe not as useful, because what we're really interested in, right, is the relationship between these variables and the thing we're trying to predict. We're interested, let's create a new section here, in the relationship of the data features with the target. So how might we do that? Well, let's take a look, first of all, at our target column. There it is, just zeros, ones, and twos. We have 150 of them. So we want to find a way to plot each one of these features with our target. And there's a lot of different ways that we can do that. To start with, I want to show you one way, which is univariate plotting with the target. So we're going to take it one feature at a time, and we're going to look at the relationship of that one feature with our target here. So let's go back up here kind of to the top. Let's copy this down here. And okay, so now we're going to use something called the SNS rel plot. And a rel plot is basically a relationship plot, I believe. Yeah, relational plot. So this is seaborn, which is the other data visualization library. And this is just going to make it easy to do this one type of plot here. So we want to pass in our X and a Y and a color. So I want to plot a column in our data. So I'll say X equals this column. And what we're doing here is we're passing the name of a column in the data frame itself. So we're passing the name of the column. We'll say Y equals target. Our hue will color our graph based on the target as well. And then we need to pass in our data here. And so we'll say data equals DF. Now let's try this and see what happens. All right, so here we go. We see that these are our different data points where the target is 0. So I believe that's Setosa, and then our 1, and then our 2. So this actually, it would be helpful here if we could see the target name instead of just the label here. So let's go ahead and take care of that really quickly. So what we want to do here is we want to, let's look at our data frame again really quickly. So rather than having a 0 and a 1 and a 2, we want to have the names of our different species in here, and we can call it a different column name. So we could have target name or something like that. So how do we do that? Well, usually what we'll do is we'll have a mapping function here. So we'll say map, in this case, we're mapping, and then a dictionary is a really nice way to do this. So we'll map 0 to, let's see, 0 to Setosa, 1 to versicolor, and 2 to Virginica. All right. And let's see. So we'll say target name is this new column we're creating. Let's see if that worked. All right, we've got Setosas here. We've got Virginicas down at the bottom, and that's looking pretty good. All right, so I'll add a little comment here that just says create new column with the species name. All right, and now if we do our, let's do our hue, rather than basing our hue on the target, which seaborn is taking as a continuous variable. If we map it on target name, we'll see the colors change down here. There we go. So our colors change to be a little bit more easily discernible because seaborn, we're now telling it, hey, we want to color by this categorical variable, which is text. These things don't have it's not actually 0, 1, 2 like it was plotting before with kind of that nice gradient of color. These are actually totally different categories. And so we want to plot them in totally different colors. So that's just kind of one of the things that we're doing there. Once again, let's add a title to this. So we'll say soup title, and we'll plot the column here. And it looks like our column name or our title is overlapping with the graph. So there is a parameter that we can add to the soup title function here, this method, which is y. And if we plug in like y equals 0, you'll see that it plots it down here. Let's plug in y equals 1. It plots it here. Let's try 1.1. It's a little too high maybe. So we're just trying to get it out of the way. And then once again, I'll do a little plt.show trick just to get rid of that one thing that printed here. Another way that we could do that, by the way, is it's printing output because of this final call. It's returning this object essentially. So whenever we do plt.soup_title, it gives us the title text object so that if we want to do something with it later, we can. So another way of dealing with this, if we don't want to output this in our cell, is just assign this to a throwaway variable. And in Python, the typical throwaway variable is just a single underscore. So I'll just assign that to a single underscore. That way it won't output it. It won't return it to the cell output. And that just cleans things up a little bit. So, all right, let's go back to looking at this graph here. So we see that our setosa is looking a little bit more different than these two. These two overlap quite a bit, the versicolor and the virginica. The setosa is a little bit further out here, and this is actually something that we will see in subsequent plots as well. So let's go ahead and plot our sepal width. And here we see kind of a different relationship, and things look to be overlapped a little bit more. Let's look at petal length. And here we go. We see very nice clean separation here. It looks like we can tell setosa flowers from the other two types of flowers purely based on the petal length, which is something that we'll actually use later. And petal width. And it's looks like we could do the same thing with petal width as well. So looks like you can tell setosa flowers based on their petals. And differentiating between versicolor and virginica, it's going to be a little bit harder. It does look like there's a pretty good relationship here for some of these where we can tell the difference. But this is why we do data science and machine learning. This is a pretty simple problem, right? Where we can see these relationships coming out pretty nicely. A lot of the times, the relationships are going to be much more complicated, and you're not going to be able to just see them immediately. And this is where the art and the science of modeling comes in. So we're going to do some models here in just a second. But first, I want to show you this really nice function that is good for doing this kind of exploratory data analysis. That's really what we're doing here, is exploratory data analysis. And I'll actually put that here. So exploratory data analysis, which is also called EDA. People call it EDA a lot. Let's look at pairplots. And this is going to help us do some of the same things that we've been doing here, but with a single seaborn line of code. So we're going to tell seaborn, let's do pairplots. Let's plot our data. Let's just see what this gives us. Let's see what that gives us here. We're going to add in a couple other options here in just a second. So you'll see that it is plotting every variable in our data set against every other variable. And this is really cool because at a glance with a single command, we can see the pairwise relationships between all of our different variables. And in the case where we have something like this, where let's say it's sepal length versus sepal length here in this plot, it shows us that histogram, that distribution that we looked at earlier. Now in this case, we have our target in here. So these plots are going to be the ones that we just looked at. but we don't have color yet, and so we want to go ahead and add color to this because that helps us differentiate kind of like what's going on, helps us see what's going on a lot better. There we go. This is really nice. So now that we're plotting the different target names, you can see actually, you can see, you know how we've been saying that setosa is kind of out there on its own? We saw that in the petal length, we saw that in the petal width. We can now see it even more clearly in these two-dimensional plots. So let's take this one, for example. What is this? This is petal width on the y-axis, plotted against petal length on the x-axis. And you'll see that setosa flowers are off down here in their nice own cluster. So those are going to be very easy to identify using just the numbers of our data. Now, the versicolor and the virginica, it does look like there is a pretty clean cut there, but they definitely overlap a little bit more. So those are going to be a little bit harder to differentiate. But we're getting some pretty strong signal here, like a pretty good relationship between our input features, between our X data, and between our output target, our Y data, which in this case is the species of flower. So we're going to be able to use that when we start modeling, which is very soon.